This one is problem 1.36. In this there are 4 logs here. They are inside a truck, and this angle right here is given as theta, and they are asking what is the least angle for theta, so that when the 4th log, which is this one right here, is removed, 3 remaining logs stay where they are. Okay, so let's look at those 3 logs, and we'll separate these logs so that we can draw the free body diagram easily. So this is your first log, this one is your second log, and this right here is your third log. Now since all of these are of same size, when we draw this triangle which is connecting all the centers, these angles here are going to be 60 degrees here, these angles. Now in terms of forces, all of these will have their weights, and the weight is going to be acting downwards. So W here, W here, and W here. Let us name these logs. This one I'll call A, this one B, and this one C. Now in terms of contact forces, on this one there will be a normal reaction NA, and this one there will be a normal reaction NC. Now this we are drawing when the 4th log is removed. Okay, so in between this A and B there will be these contact forces which is equal and opposite. We can call this FAB. Similarly here we'll have these contact forces FBC, and likewise here this is going to be FAC. Now on log A, because of this wall support on this side, there will be another force, and because of wall, let's call that FW. Now since the problem is asking about these logs to stay together, let's look at the boundary case when these logs are going to be separated from each other. Okay, so this has been removed, and as soon as this is removed, what will happen? This log will come down and these two will separate from each other. So in that process, this FAC force that we have here, since this contact will be lost, this will become equals to 0. Now to resolve these forces, let's attach a coordinate system here. So this one here is your x-axis, and perpendicular to that is your y. Now let's look at the forces on this C log and B log. So I'll draw one coordinate system first so that we can draw the forces, and this one is your C log. So in terms of forces, we have a vertically downward going force, which is your weight. Along the y direction we have this force which is the normal reaction, and then we have this force FBC which is pointing this way, and the angle it is making with the x-axis is 60 degrees. Now since this angle right here is theta, and this W force will make an angle theta here from the y-axis. So this angle right here is going to be y-axis. So on log C, if I look at the forces in the x direction, this force right here was FBC. So FBC cos 60 degrees, which is going to be in the positive x direction, will be opposed by a component of W that is going backwards, and it's going to be W sine theta. So from here we can get the value of FBC equals to W sine theta divided by cos 60 degrees. Similarly, if I draw the B log there, and this is your x and this one is your y, the forces on it are going to be your FBC, which is going to be this way, taking it from here and applying it exactly in the opposite direction. So this is your 60 degrees. So this one is FBC, and this FAB force, which is going to be this way, and since this angle is 60 degrees here, so it's going to make an angle 60 degrees from the x-axis, and we have weight going downwards W with this angle as theta. So now we can do the force balance in the x direction and the y direction. So if I look at summation of forces in the x direction, I can write FAB cos 60, that is going positive x direction, minus FBC cos 60 going backwards, and minus W sine theta equals to 0. Similarly, if you look at summation of forces in the y direction, we can write one equation which says FAB plus FBC, because both of them are going to give you sine component going up, minus W cos theta equals to 0. So from here we can solve for FAB and FBC, because there is first equation, second equation, two unknowns. So we can solve for both of these forces, and the value of AB is W over 2 cos theta divided by sine 60 plus sine theta divided by cos 60. This is basically summation of two equations and subtraction of these two equations. And similarly, WBC is cos theta divided by sine 60 minus sine theta divided by cos 60. So now we have an expression of WBC here, another expression of WBC there. So I can compare both of them. So W sine theta over cos 60 goes here, is equals to W over 2 cos theta over sine 60 minus sine theta over cos 60. Now if you cancel W here and solve for tan theta from this equation, 1/3 cos 60 divided by sine 60, and this gives us a theta value which is 10.89 degrees.